Hey, this is Dwight Dunn from Dunn's Tutoring, and today we're going to complete a video here on a very important topic or a very tricky topic, and that's going to be integrals. So we're going to address some integrals here that are a little bit tricky depending on the student. These are questions that was taken from an actual test that I gave to students, and very often they are not some students are not very clear in terms of how to approach these problems. So hope you're staying safe before I begin. I'm in this quarantine and just try to stay above water and at the same time try to enjoy some elegance of mathematics. So let's look at these three problems. These three problems look very, very similar, but yet very, very, very different. Now, one of the things that I want you to keep in mind, these problems are done in the context that we are preparing students for Calculus 1 or AB Calculus. So look at the three problems, very similar, but yet very different. So the first problem is very, very easy once you recognize it is of this format. So if it's of this format, f of x to n, f of prime, that's the derivative of f of x, here we can actually do it using this result. Now, one thing we need to be aware of, if I didn't recognize this method, I could actually use substitution and try to figure out how to approach it and try to arrive at the final answer. Now, with that being the case, let's try to get it in this format. To get it in this format, I'm going to bring that 3 outside because I can put a constant outside of the integral. Then I'm going to have x to 3, which here going to be 5 minus x to the 4th all to a half, because I know then that the square root of 5x to the 4th is the same thing of all of that raised to a half dx. Now, once I have that, again, I'm going to go one more step. This is going to be x to the 3rd times 5x to the 4th to negative a half dx. Now, by mere observation, I just need to recognize what is my f of x to n and what is my f of prime. So here, if I differentiate this piece, this is going to be negative 4x to the 3rd. So I simply can put negative 4 here, and that would be the exact derivative of what is inside here. If I put this negative 4, I'm going to have to take it out back, so that's going to be negative 4. Now with that, this now is of that format. So all I simply need to do, I'm going to have negative 3 over 4. Then this is going to be 5x to the 4th negative a half plus 1 divided by negative a half plus 1 plus c. Now to simplify, that's going to be negative 3 over 4. This here going to be 5 minus x to the 4th to a half divided by a half plus c. Now keep change flip. I'm going to have negative 3 over 4 times 2. That's simply the same thing as the square root as 5 minus x to the 4th plus c. To simplify, I get negative 3 over 4. And let me just write it right here. So that's going to be 2 into 4 going to be 2. That's the square root of 5 minus x to the 4th plus c. So this question is a no-brainer. Pretty simple if you spot the pattern early, and you can actually do it in a number of steps. Now, the second problem we want to approach is very, 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 very similar. Again, we want to be cognizant of the fact that we cannot use the method before because we know that the derivative of this is negative 4x to the cube. So the challenge with this problem is just to recognize that it's of this format. If you recognize it's of that format, then it's going to be a simple breeze. Now, by mere observation, a right there going to be equal to the square root of 5. If a squared is 5, then we realize that a must be the square root of 5. Also, u going to be equal to my x squared. So if u is equal to my x squared, we're going through substitution process for this problem because again, this problem can be a little bit tricky depending on the particular substitution. Some students tend to miss a value here or there. So if you're very good, you can do this in one step using observation. Or if you're not so good and you don't want to make any mistake, you want to make sure that you go through and use the substitution process because that would prevent you from making a mistake. Now, if I differentiate this right here, this is going to be du with respect to x, dx equal to 2x. Now, this is going to be, if I flip this, it's going to be dx over du equal to 1 over 2x. So my dx, let me get some space, going to simply be equal to du over 2x. So now in my initial problem, let's do some substitution right here. So the integral is 3 right here. I'm going to bring that 3 out, keep my x right there. This is going to be 5 minus. Now, again, I recognize that I'm substituting u to be x squared. So this is going to be u squared, square root of that, times du over 2x. X, drop that x out. So I'm going to get 3 over 2 if I bring that constant out right there. Now, I'm going to have 1 over 5 minus u squared, square root of that. Now, with that being the situation, let me put back my integral. This is going to be over du. And if that is over du, I realize now that this format matches what was initially given to us. So if that matches what was initially given to us, the result going to simply be 3 over 2 sine inverse. I need my u, so u is going to be on the top divided by my a going to be the square root of 5 plus my c. However, my initial substitution for u was x squared, so that's going to be 3 over 2 sine inverse x squared divided by the square root of 5 plus c. And that completes the integral for the second problem. Again, notice that they are very, very close, but very, very different. So just be careful with those two, that you don't mix those two up. Now let's look at the third problem. Now, if I try to approach it using my substitution, let's try to see if we can use the trig inverse or the arc sine to actually do this problem. I realize that if I do the substitution of u equal to x squared, if I differentiate that, I'm going to get 2x. So again, I'm out of a variable for the top, because that's 2x. Notice I cannot bring a variable in and out of the integral sign, so that won't work. If I try my other method by trying to spot that we have the function times the derivative, I realize that won't work either, because the derivative of the bottom right here is negative 4 x to the third. Again, I'm out by a variable, and I cannot bring a variable in and out of the integral. So within the scope of calculus 1 or AB calculus, remember that was our initial scope, this problem cannot be done. Now, if we go on a little bit further, a little bit higher, we could try to figure out some more advanced techniques, how we could actually figure out what is the integral for that function. So I hope you enjoy this session. This is Dwight Dunn from Dunn's Tutoring, satisfying all your math tutoring needs. Please subscribe to my channel and check me out. Have a phenomenal day, and remember, stay safe.